Once you've gotten all the past observations from the U.S. Naval Observatory, what you're going to want to do is find your text file for your particular double star pair. Open that up. It's a whole bunch of data. Select all of it, Control A, copy the whole thing, Control C, open up a Word document, set the layout, orientation to landscape, Control V to paste it all, so now you have all of this data. And what we're really interested in is all of the past observations. So you can see the dates here on the left. This double star has a particularly large number of observations going all the way back to 1821. So you're going to select from this file all of the observations. And we're going to put all of this into a spreadsheet. So, all right, you'll notice that there's a couple different sets of observations. STF 1321AC, that's looking at the primary star, and component C, we're really only interested in the AB pair. Notice the first one is the AB pair. So again, we're only going to select the data from there down to the end of the AB measurements, which are somewhere in here, right there. We're going to Control C, copy all of that, open up our spreadsheet, paste that all in there, and now we want to convert that all to columns. So notice this is all contained in column A, so the first thing we're going to want to do is go to Data, Text to Columns, Fixed Width. It shows us what it's going to look like. We'll just hit Next, Fine, Finish. So notice it's now broken it all up into columns. Now there's a number of things that we don't need. We don't need column C here, which is just empty, so we'll right click and delete that. Columns D through H is all magnitude data, which we don't actually need right now. So we can delete that. Column, let's see, so the columns now are the date. We can actually, let's insert a column here, or a row rather. Insert a row here. This is the date. This is the position angle. This is separation. This is the aperture of the telescope. This is the number of observations, discovered code, and this is the observation type. And these are notes. Okay, I'll clean this up a little bit. All right, now one thing we're going to want to do is get rid of data that has missing components. For example, number 9 here is missing the separation. We can't use any data points that are missing the date, the position, angle, or the separation. So we're just going to go through and delete that. Right now we're going to do a simple deletion of anything that's missing data in those 3 columns, which is pretty okay mostly. Oh, that's missing information. So we're just cleaning up the date so that we can then analyze this data, make plots of different parts of it. So delete that one. Okay, the other kinds of things we're going to want to fix, and we can delete this one. The other kinds of things we're going to want to fix are here. There's more information in this cell than we need for our analysis, so we're going to just delete that. Again, same thing here. Delete that. And getting out anything that might mess up our graphs and make things appear as outliers that probably should not be outliers. Here's a bunch of these. All right, we need to get rid of some of the cues that you'll find here and the dates. Now, one thing you'll want to pay attention to is the dates need to all have decimals. These are measured in fractional years. These are fractions of years. That's what the decimals represent. So if someone reported, for example, there's a 1950 in here, it's highly unlikely that this data was collected at midnight on December 31st of 1949 or just thereafter. So we can delete that data. Otherwise, that will show up as an outlier. Okay, now the data is mostly cleaned up. Just to make it slightly easier to read, I like to have these all centered. I feel like it's easier on my eyes. But we've taken out all the bits of information that could mess up our graphs. So now we have fairly cleaned up data, which we can start to analyze. For example, we can make a graph of the position angle versus date of observation. Take a look at what that looks like. So we highlight the data, go to Insert, Chart. Let's go to More Line Charts. Select an XY scatter. Here we go. Double click and take a look at this. This is a very lovely graph. Okay, I'd like to zoom in on this graph a little bit. So notice there's no data lower than 40 or higher than 100 on the position angle. So I'm going to double click on that and make those bounds the minimum. Make that 40 and make this 100. That's going to sort of maximize the XY direction. And we can do the same thing down here. There's no data before, that's about before 1810, I would estimate, and no data after 2025, since that hasn't occurred yet. We can just stretch this out a little bit, 1800, 25, okay. Those should be fine. So our data is stretched out so we can see all of these observations. It looks fairly linear, good consistent data. A few outliers. If you mouse over them, you can see which data points those are. You can always check the references on those later. So you can just start to play with your data. So there's one question. How linear is this? We could look into something like that. We can make another graph of, for example, position angle versus separation over time. Let's see how that looks. So again, we're going to insert, choose More Line Charts. Let's look for XY scatter. Let's take a look at that, double click. All right, here's the graph for that. Now this is an interesting one. Ooh, there's a couple of outliers going on down here. We'll have to look at those. Saying we have a data point of 0, so that's, we better go look at that data point. Maybe not. Separation 57, 0. Okay, found one of those points. Notice here. Here we go. Okay. We need to remove this data point. It's missing the separation. So let's delete that. And that point went away on the graph. Notice right there. We have another problem right here. This did not get adjusted. Let's fix that data point, see if that makes a difference. Yep, that adjusted that point. Okay. Then we can look at our outliers and figure out what's going on. And again, we can stretch this graph. There's nothing below 40 or above 100 again. It's always a good idea to stretch your graphs out as much as possible. Okay, and there's nothing below 15 or above 22. So now we can do the same thing for this axis. There's nothing below 15 or above about 22. So let's put that there and make that perfect. Okay, so now we can see a little bit better what's going on with our trend. let's take a look at how this might match up with the orbital diagram that we got from the U.S. Naval Observatory. So we can pull up our information from the U.S. Naval Observatory, and here's that orbital diagram. Now let's take a look at, right now we're graphing the position angle versus separation over time. The position angle, as this is fairly close to circular, not exactly, but fairly close to circular, therefore the position angle wouldn't be expected to change very much over time. That would be Kepler's second law, equal areas are swept out over equal time. However, you'll notice that the separation between the primary and secondary star is decreasing over time. Down in the original data points, it was a larger separation and it gets smaller and smaller. So let's go back and take a look at our graph, which indeed shows the separation decreasing over time. All right, so there would be lots of other interesting questions one could ask when looking at all of this data. For example, you can take a look at the different observer codes, and you'll notice in the 1970s and 80s there were two observatories that were collecting a lot of data. This PKO observatory in Russia and the U.S. Naval Observatory started doing some pretty intensive observations in the late 60s. Notice they were observing a lot of data released in 1974. They observed a star for 5 or 6 years. Again, more from the PKO Observatory in Russia. So it would be interesting to take a look at what are their observations. What's the sort of the standard deviation in their observations over the years. You can compare different observatories. You can compare different aperture telescopes. The U.S. Naval Observatory and the PKO observatories are both 0.7 meter. However, there are other observers, 0.1 meter telescopes, 0.2, 0.3. It would be interesting to take a look at maybe how the different apertures give hopefully the same, but you could look at variations in the data from those. So it's a whole lot of data to play with. Have a good time exploring.